Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Okay, so in this video we're going to be looking at the November 2019 and it's paper 1 for Edexcel and it's the non-calculator higher paper. Okay, so please do stop the video, have a go at each of the questions and then compare your solutions. Let's move on then to question number 1. Find the LCM of 108 and 120. So the thing with LCMs is that really you need to start with a factor tree. So if I start with 108 and then what I would normally do is divide by 2 until I get to the point where I can't divide by 2 any further, and then I would start to divide by 3. And this will give me a fairly neat kind of pattern, a little bit like I guess a hockey stick or something like that, and it just makes it a little bit easier to follow the factors as we're working through, because we're going to put these factors into a Venn diagram. So as I'm working down here, I'm dividing by 2 each time, and then I get to an odd number 15, I'm going to start dividing by 3 and then by 5 because I can't do anything else with it. Okay, if I now create the Venn diagram, I've got effectively the factors of 108 and the factors of 120. Now the reason I mentioned about hockey sticks before is I can look at my factor tree and I can tick off the 2 which is common to both 108 and 120, and I can do the same with the next 2 and put that in the middle, and then it's a little bit easier, not entirely but a little bit easier for me to see that 3 is also common. So basically what I've got in the middle there is effectively the highest common factor. However, the question is looking for the lowest common multiple, so I need to complete and put in the 3 and the 3 for 108, and also the 2 and the 5 for 100 from 120 from the factor tree itself. So the LCM is simply the multiplication of all of the numbers within the Venn diagram. So I'm just going to write them out as you would see them, not in ascending order. That's 3 times 3 times 2 times 2 times 3 times 2 times 5, and when I multiply all of those together I'm going to get 1080. Now I know I'm very aware it's a non-calculator paper, so you will need to do a little bit of work on that, which I haven't done for the purposes of this particular video. Okay, let's move on then to question number 2. So question number 2, and this is one of those wordy type problems that you just need to work through very carefully and methodically and slowly. There are 60 people in a choir. Half of the people in the choir are women. So therefore what we mean by that is that 30 of them must be women. Then it says the number of women in the choir is 3 times the number of men in the choir. Well, if there's 30 women, then it would basically mean if it's 3 times, then there must be 10 men. Okay, so I've only really got to the 3rd line here, and already I'm starting to tease out a little bit of information from this particular question. Okay, so this line that says the rest of the people in the choir are children. Well, we've accounted for 40 people. We've said 30 women and 10 men. There's 60 people altogether, so therefore there must be 20 children. Then it says the number of children in the choir is proportional to the number of men in the choir in the proportion of n to 1. So again, really wordy, but basically what we're saying is that children as a ratio to men, well, we know there's 20 children and there's 10 men, and they want that in the ratio of n to 1. All they mean is that this number here must be 1. In other words, I've divided through by 10. Therefore, if I divide the other side through by 10, I'm going to get 2. So my answer is 2 to 1. And that's the answer to that particular question. So lots and lots of words, but once you take it methodically, take it slowly, you should be able to come up with something that will get you a couple of marks. It is actually a 4-mark question. Okay, let's move on then to question number 3, which is a fairly standard multiplication of fractions. So I'm going to change them into top-heavy or improper fractions. So 1 3/4, well, 1 times 4 is 4, plus 3 is going to be 7 over 4, multiplied by 4 over 3. Okay, now I can either multiply across and say, well, that's 7 times 4 is 28, divided by 4 times 3, which is 12, and then reduce. However, I'm just going to reduce because it's fairly easy to do that. I can divide top and bottom through by 4, so that's going to give me 7 over 3, and that's going to give me then 2 1/3. Now, just as a point, if you're not sure about any of the questions on these particular papers, let me know, and there are playlists on the rest of the channel that you'll be able to have a look at. Okay, so let's move on then to question number 4. Now, this is going to be quite tricky on a video to show, but basically you need to use a pair of compasses. And what we're trying to achieve is that we want to create effectively an isosceles triangle. So therefore, if we use a pair of compasses and we take the distance between P and D, we can then create a point over here, I'll just call it X if you like, where the distance between X and P is exactly the same as the distance between P and D. Now, the reason we want to do that is because we can then use our compasses to get the midpoint of the line XD, and the way we would do that is we would put our compasses onto point X, and we're going to draw a nice kind of arc like that, okay, and then on point D, and we're going to draw a nice little arc the other way, okay, and then if we draw a line, it's an awful diagram this, but if we draw a line through, what we're going to get is the midpoint of the line XD. So I'm really sorry about that. That's probably about the worst diagram I could ever do. Let's just see if I can just tidy that up a little bit, and hopefully you'll get the idea of how these things work. I probably need to do a separate video on this entirely. Okay, do let me know in the comments. Okay, so let's move on then to question number 5. Now, the important thing with question number 5 is that it says the size of angle DCB to the size of angle ACD is the ratio of 2 to 1. So what we're basically saying is that ACD, if that was X, then the value of DCB would actually be double that, which is 2X. Now, it's important because that will allow us then to find a value for X on this particular triangle. Okay, because if I look at the overall large triangle, which I'm going to call triangle ABC, that's going to be made up of 3 angles. It's going to be made up of a value of 51, which is the bottom left hand side there, a value of 75, which is the top, and then a value of X plus 2X, which is 3X. Okay, now we know that the internal angles of a triangle will add up to 180 degrees. So I can say 180 degrees equals 51 plus 75 is going to be 126 plus 3x. Take 126 from both sides, I'm going to get 54 equals 3x, and then divide through by 3, and finally I'm going to get x equals 18, which is excellent because it tells me then that this angle over here is going to be 18 degrees, and then angle DCB, which is important to us, is going to be 2 lots of 18 degrees, which is actually going to be 36 degrees. Okay, now we're being asked as a question here to work out the angle BDC, which is this angle at the top here. So what I'm going to do now is ignore the large triangle, and I'm just going to focus entirely on triangle BDC. Now again, I'm looking at all the angles here. Bottom left hand side is going to be 51. And then the top of BDC is actually the angle we're looking for, which I'm just going to call angle BDC. Okay, and then finally on the right hand side I've got the value of 2x, which is going to be 36 degrees, so plus 36. So what we're really saying, as we did before, is that 180 degrees, which is all the internal angles, are going to equal 51 plus the top angle that we're looking for plus 36. So let's solve for x then. So 51 plus 36 is going to be 87 plus angle BDC. If I take 87 away from both sides, I get that 93 degrees equals angle BDC, which is actually the answer to this particular question. Okay, hopefully that's okay for you. Let's move on then to the next question, which is a mean type question. Which is all about finding the mean. These are very common questions. I would suggest that you do practice these. If you want to have a look at 3-minute maths, there is a topic test on working out means, or if you send me a comment, then I will send you a link through to it. Okay, so again, as we had before, we need to read these through fairly carefully. So let's just look at the 4 red bricks that have got a mean weight of 5 kilograms. So let's have a look what that means. So if we look at red, the mean equals the total divided by the number. So in other words, we know that the mean is going to be 5. We know the total, or rather we know the total is going to be all the weight of all the bricks added together, and this is what we're actually going to be looking for. But we do know the number is going to be 4 bricks, okay, 4 red bricks. So therefore we can work that out to say that actually the total weight of the 4 red bricks is going to be 5 times 4, which is 20 kilogram. Okay, well that's going to be useful to us because when we work out the mean weight of all of the bricks, we need to know that for the red. So let's have a look at what's happening then with the blue bricks. And again, we've now got exactly the same bit of information, 5 blue bricks, but this time it's got a mean of 9 kilograms. So again, I'm going to write it out as mean equals total divided by number. Now I'm very aware not everybody will write formulas in the way I do. I always write them out every single question because it helps to cement it in my mind. So the mean is going to be 9. The total weight of the blue bricks I don't know, but I do know there's going to be 5 of them. So therefore I can figure out that 9 times 5 is 45. So the blue bricks, the total weight is going to be 45 kilograms. Okay, and then we're left with a green brick which has a weight of 6 kilograms. Okay, so therefore we can work out the mean of all the bricks. So I'm just going to roll up a little bit there. So if I look at now all the bricks, well, the mean, guess what, is equal to the total divided by the number. So that's 3 times I've written the formula. Okay, so the total is going to be the total of the red bricks, which is 20. The total of the blue bricks, which is 45. The total of the green brick, which we're told is 6. Now we've got a total number of bricks of red is 4 of them, blue is 5 of them, then there's 1 green, so therefore it's going to be 10. Once I work all of that out, I'm going to get 71 over 10, and 71 divided by 10 is equal to 7.1. Okay, so is Donna correct? She's not actually, because it's closer to, well, in fact it is 7.1 kilograms, not 7 kilograms. Okay, hopefully that's okay for you. If you're not sure, let me know in the comments. Alright, let's move on then to question number 7, which is going to be the next question on this particular video. And we've got p to the power of 2 5 times. So if you like, and again I wouldn't do this too often, but it's going to be p2 times p2 times p2 times p2 times p2. Okay, add up all the indices as you would, and that's going to be p to the power of 10. Or if you know the laws of indices, you just multiply 2 times 5. Okay, simplify. Well, I'm going to write this actually as a fraction. I find it a little bit easier to write it as 2x to the 7 y to the 3, all divided by 6, x to the 3, y. Okay, because I can just work through methodically. So if I look at the number, or the numbers, I've got 12 divided by 6, which is going to give me 2. And then I've got x to the 7 divided by x to the 3. Well, we're going to subtract the indices, so that's going to give me x to the power of 4. And then I've got y to the 3 divided by y. Now that's the same as saying y to the 1, so therefore that's going to give me y squared, which is the answer to part B of this particular question. Okay, let's move on then to question number 8, which is a bearings question. Now this is one of those questions that really doesn't come up very often, but causes a little bit of confusion. So I'm going to go through this fairly slowly, if that's okay with everybody, but again, if you're not sure, let me know in the comments. Okay, now I haven't got a protractor on the screen, so I'm going to have to do this fairly I'll do it as a sketch. Okay, so let's have a look. So it says that Alina sails her boat from port P. Okay, so we're right at the bottom here, from port P on a bearing of 70 degrees. Okay, well that's fine. So bearings are always north clockwise. Okay, so what I'm going to do is, using a protractor, I would measure 70 degrees, okay, from the north. So that would be 70 degrees, and that's the bearing of Alina's boat. Okay. Then she sails for 1.5 hours at an average speed of 12 kilometers per hour to a port Q. Okay, so that would be then 1.5 hours at an average speed of 12 kilometers is going to be 18 kilometers. Okay, because 1 kilometer will be 12. And then half a kilometre or half an hour will be 6 kilometres, so 12 plus 6 is going to be 18 kilometres in total. Now it says the scale 1 centimetre represents 4 kilometres, so if I divide that 18 kilometres by 4, what I'm actually going to get is a distance of 4.5 centimeters actually on the diagram itself. So if I measure 4.5 centimeters to point Q, okay, it will then give me the location of port Q. Okay, so then it says the two questions are: find the distance in kilometres of port Q from lighthouse L. So let's have a look at lighthouse L. Now what you would need to do is just measure this on your particular drawing. Now again, I've done it fairly sort of as a sketch, but if I look at answer to question number 1, this is a distance of 5.5 centimeters on the drawing that I actually did. Okay, now don't forget the scale, so each centimeter represents 4 kilometers, so it's going to be 5.5 multiplied by 4, and that's going to give me a total of 22 kilometers from lighthouse L through to port Q. Okay, and then part 2 of the question is the bearing of port Q from lighthouse L. Okay, well again, you would need to measure it, but don't forget that bearings are from the north clockwise. So what we're looking to do is to get this dimension. Okay, now on the particular drawing that I did, I got this angle as being 39 degrees. Okay, so what I'm going to do is say, well, that's the same as saying 360 minus 39, and that's going to be therefore 321 degrees as a bearing, and that would be the answer to that particular question. Okay, hopefully that's okay for you. Do please let me know. Okay, so we're going to finish off with a couple more questions, so I'm going to move on then to question number 9. Question number 9 is what they call compound measures. This particular one is a car travels for 18 minutes at a speed of 72 kilometers per hour. How far does the car travel in those 18 minutes? Okay, well let's have a look at our formula. So the formula is always speed equals distance divided by time. Okay, well what we do know is that the speed is 72 kilometers per hour, and the important thing here is it's per hour. Now we've been given the time as 18 minutes, so what we've got to do is convert that to hours. So the easiest way to do it, I think, it is using a calculator or using some form of calculation, but basically it's 18 out of 60 minutes, and that will give you the part of the hour that you actually want. So therefore my calculation is going to be 72 multiplied by 18 over 60, because don't forget, when we're dividing by fractions we multiply and flip, and that will give us our distance. Now again, I'm not going to spend too long doing these sorts of calculations, but hopefully that will be okay for you, and that will give me a total distance of 21.6 kilometers. Okay, so again, let me know, there are some playlists that you can have a look. Then it says part B, 72 kilometers per hour is faster than 20 meters per second. Now again, very popular type of question, so let's have a look at how we could work that out. We've got 72 kilometers, and I'm just going to write in each hour, so 72 kilometers per hour each hour. Okay, so what that would mean then is if I looked at that as meters, what I would say is that's the same as saying 72,000 meters each hour, because there are 1,000 meters in a kilometer. Okay, now I want to work out per minute, so what I'm going to do is divide through by 60, and if I divide my hours by 60 to get my minutes, I have to divide my 72,000 meters by 60 as well. So what I'll end up with is 1,200 meters, and this is now each minute. Okay, so we're getting a little bit closer. So to go from minutes to seconds, I need to divide by 60 again. But of course, I've got to divide the other side by 60. Okay, so that's going to give me 20 meters each second. Okay, so is David correct? Well, it's not faster, it's exactly the same. So 72 kilometers per hour actually does equal 20 meters per second, and that would be the answer to that particular question. Okay, so I think what we'll do is stop there at this point. That's going to be the end of question number 9, and we'll start in the next video from question number 10.